Hi and welcome. In this video, you will learn how to find the eigenvalues and eigenvectors of a square matrix using numpy in Python. Eigenvectors and eigenvalues are widely used in machine learning libraries. In linear algebra, an eigenvector is a non-zero vector that changes by a scalar factor when a linear transformation is applied to it. The corresponding eigenvalue, often denoted by lambda, is the factor by which the eigenvector is scaled. In practical terms, given a linear transformation represented by a matrix A, eigenvectors are vectors that when the transformation is applied, change only in scale, not direction. It can be represented by this formula. AV equals lambda V, where A is a square matrix, lambda contains the eigenvalues and V contains the eigenvectors. Using linear algebra tools in the numpy library, we can easily calculate eigenvectors and eigenvalues of any square matrix using the method EIG. Let's now go to practice. First, we need to import the numpy library. As an example, we are going to create a 3x3 matrix. We can calculate eigenvalues and eigenvectors using the method EIG. Notice that in this code, we created two variables, one to store the eigenvalues and another one to store the eigenvectors. To display the eigenvalues, we just write eigenvalues, like this. To display the eigenvectors, we just write eigenvectors, like this. As you see in the output, we have 3 distinct eigenvalues and 3 eigenvectors. With this, we finished the video, where you learned how to find the eigenvalues and eigenvectors of a square matrix using numpy in Python. If you liked this video, make sure to subscribe for more. Thanks for watching, and I hope that was helpful.